So Bismillahirrahmanirrahim. In this third video of chapter Transformer, I'm not sure, fourth video of chapter 2 Transformer. So I will explain on how do we calculate VR and efficiency if we are using referred to secondary. So during our previous class, we have already answered question 3, part A. That is, we have already sketched the parameters of approximate equivalent circuit referred to primary and secondary side. So we have the answer referred to primary and referred to secondary, both approximate equivalent circuit. We have both of them. Okay, so number B, determine the copper loss and core loss of the transformer at 0.8 power factor lagging. Okay, so and C is find the voltage regulation and efficiency at 0.8 power factor lagging. So in this video, I'll show you the solution if you are using referred to secondary. If you read through the question, it's not stated whether you need to use referred to primary or referred to secondary, right? So it's up to you to use which approximate equivalent circuit that you like. But for this video, I'll show you if we use referred to secondary. So another thing is, notice in the question, it's not stated whether the transformer is operating at full load or 50% operated load or whatsoever. So in this case, we can assume that the transformer is operating at full load. In other words, your N is 1. Okay, so moving on to the okay, so since we have decided to use the referred to secondary, so that is the circuit referred to secondary. So RCS 228, XMS 37, R equivalent S 0.04, X equivalent S 0.05. So to find copper loss and core loss, so formula for copper loss is from this, IS squared times R equivalent S. So you need to find IS rated first lah. That is from the formula S rated over VS rated equals to, from the question, 20K divided by 220. In here, 20K divided by VS 220. Okay, so you get 90.9. And the question asks you to find at 0.8 power factor lagging. So angle of current is negative. Okay, so cos inverse your power factor, you get negative 36.87. And then just take the magnitude of IS times with R equivalent S from your circuit. So you get 350.34. Okay, so in this case, you don't need to multiply IS with N because your N is 1. You assume full load. Alright. So you might be wondering, why didn't we take the angle as well? So just think it like this. You are calculating power. Power is real number. Okay. It only has magnitude. So just take the magnitude when you calculate it. Okay. Moving on to find core loss. Okay, core loss is the loss at RCS, that is VP over A squared divided by 228. Okay, VP over A squared divided by 228. But that VP over A, you need to calculate using KVL. KVL around your referred to secondary punya circuit. So VP over A equals to IS times R equivalent S plus JX equivalent S plus VS. Okay, so calculate IS from the previous question. Why now we need to insert angle of current? Because you are calculating voltage. Voltage consists of magnitude and angle. So we cannot simply ignore angle. Okay, R equivalent S, X equivalent S from the circuit, VS from the question. So there you go. That is your VP over A. So just when you calculate P core loss, because we are calculating real power, just take the magnitude lah. 2 to 5.85. So that is your core loss. Again, in this KVL, we don't need to multiply IS with N because your N is 1. You can also put 1 here, but you get the same answer. Okay, so this question settle core loss and copper loss. Number 2 and number C, dia nak VR and efficiency at 0.8. So, okay, VR and efficiency at 0.8. So, VR, because we are using referred to secondary, right? So, front minus back divided by back. That's why it's important for you to write down the term accurately. If it's AIP, then write it as AIP. Don't just write it as IP. If it's VP over A, write it as VP over A. Okay, so in this case, your VR is VP over A minus VS over VS. So VS, no problem from the question, 2 to 0. VS rated. Here, here 2 to 0. And then, that VP over A, please make sure you get it from the KVL. So you have already calculated your KVL just now. So just take 2 to 5.85. 2 to 5.85 minus 2 to 0 divided by 2 to 0. You'll get that lah. Okay. Voltage regulation low, normal. The lower the better. Okay. And then the efficiency is P out over P out plus P copper plus P core. So first, calculate your P out. P out equals to either S cos theta or IS VS cos theta. But okay, but in the notes, okay, the formula for P out is written as VS IS cos theta. But actually, this VS rated times IS rated equals to your S rated. So that's why you can use S here. But your N is still there lah. But in this case 1. So you don't need to multiply it with 1. But if you have N 0.5, just you need to times 0.75 times 20k. That is your S rated from the question here. 20k. Okay, times power factor. So you get P out. Okay, P copper and P core you have already calculated in question B. So P copper 350, P core 223. So 350, 223. So notice that we should have N squared here, but because your N is 1, so there's no 1 there because you get the same answer. So efficiency is 96.54. So hope you get the idea, and you really need to know on how to calculate VR and efficiency using referred to primary as well as referred to secondary. Never mind, don't worry, we'll do more exercises on it. So thank you again. I apologize for all the mistakes, correction, lacking. Okay, so thank you. Assalamualaikum.